Great. Well, welcome everybody today. Good afternoon to all of those of you joining in Europe. Good morning to those of you joining from the US. I'm absolutely delighted to have with me here today Simone Battiferri, the COO of Cellnex. So, Simone, welcome today.
Thank you, James, and hello, everybody.
Great. So we've got I've got a kind of few questions that I'm going to go through with Simone, which hopefully will address, I think, a lot of the topics that people are focused on at the moment. But at the same time, we also want to make sure this call can be as interactive as possible for people. So you'll see at the bottom we have a Q&A box as well. If you have questions that you would like to ask during the call, do put them in there and we will try to do everything we can to come to those during the call. So as we said today, what we're going to be focusing on really is the kind of technology side of the tower networks, rather than necessarily the kind of financial aspect of Cellnex's business today. So also when kind of thinking about questions one might want to ask in the box, please do bear that in mind in terms of the focus for today's call. So, Simone, I thought maybe a kind of good place to start is, it's really, I mean, obviously you are talking with your customers, the mobile operators, really all the time. I suppose, good place to start is how do you see from the discussions you have with them, really the requirements for mobile service quality to evolve going forward from here?
Well, James, so let's start saying that the concept of quality is very different depending in the region of the world. Last year I have been visiting the Far East, Japan, Korea, and that's really impressive what they consider good quality. For a Japanese person, not to have, for example, connectivity inside the elevator, it's something unacceptable. This is very far from the European reality. What is true is that in looking at the statistics today, Europe is not leading the quality of service on mobile networks. And the reason is relatively simple: is probably 15 years that we are as Europe underinvesting in respect to other regions of the world for many reasons that I'm not going to talk about now. But this is the starting point. At the same time, I think that what I see today, let's divide between today and tomorrow, because there are a lot of fancy things like AI, 5G SA, and other new services, wearables, and so on, that are probably a very interesting driver for the future, but at the moment with a very little impact. Then we can elaborate more, of course. Today, what we see is that the demand is mainly driven by, let's say, three factors. One is the traffic increase. There's a lot of talk about traffic, sometimes also in not a very, let's say, exact way, saying the traffic is slowing down. No. The traffic is growing. What we saw is that after the launch of the 5G, that is obviously a peak in terms of traffic growth. The growth slowly went down, but what we are seeing now is re-accelerating, especially N25, beginning third quarter 26. What we see is that the traffic is increasing again in terms of growth. So only this drives the necessity to increase the network capacity, simply because otherwise network are going to collapse. It is something very easy. In the next 4 years, let's say until 2030, what is expected, it depends very much on the reports. These are forecasts, so are wrong by definition. But we range between traffic per 3 or per 2. So there's no network that can resist this level of increase without investing in increasing capacity. Then we go to the, let's say, more innovative part, talking about AI and 5G SA, for example. what we see is that AI is still a very small, very limited portion of the traffic, as we are talking about one single digit in terms of share, but it's a very different technology in terms of needs. But we can get there later because latency is much more important because downlink uplink ratio are different. Same thing about 5G SA. 5G SA in general terms is not a technology that is that force you to change the grid because it's more about let's say the core systems of the networks, but that indirectly will produce new growth in terms of traffic infrastructure needs, and so at the end physical infrastructure to put new equipment. So let's say that today what we see is that the demand is mainly driven by, let's say, traditional services. That is traffic increase due to handset penetration and also not secondary FWA. FWA is taking a big part of the traffic share, is growing. That is another interesting phenomenon because it's something that was thought to serve rural areas and now it is not anymore used only there. And at the same time, one FWA user consumes something like 20 times an handset. So this is generating a big traffic on the network. So just to summarize, I think that what we see is that traffic increase and demand for quality increase. This translates physically in more dense network, higher frequency because more capacity is needed, higher frequency, lower coverage, need of more infrastructure. So we continue to build site and we continue to collocate POPs. This is what we are seeing in the market. So the demand is there and is still strong.
So how are you, I mean, that's all like super interesting. Lots of different use cases you talk there, ranging from kind of elevator usage, AI, FWA, 5G SA. Could you expand a little bit more, though, Simone, on what you just said there at the end, then about kind of, let's say, more densification, more infrastructure? From the discussions you have with the MNOs, if they are seeing demand for those use cases from their customers, how does that actually translate through, though, then into kind of Cellnex's business? Is it simply just we're going to see more tower sites being built out, or kind of, how do you think about where we're going to see this impact your business specifically?
Well, look, I think that our customers are very, very selective on investment. So what we see is that, first of all, it is not only a macro tower topic. They need to increase the quality of their service and to serve, if not better, at least at the same level, the customer in an increasing traffic scenario. This means that is a side-by-side work. There are sites in which they need more antennas. There are sites where they need to complement the macro with small cell. And there's a big trend about indoor coverage because at the end, half of the time we use our cellular phone inside a building. This is something very interesting. So it's true that the penetration of terrestrial network is relatively good inside building, but it's not fantastic. So in some cases, especially where the density is very high, I don't know, like stadiums or train stations, not talking about transportation, that is another topic. In this case, what we need is the number of nodes that we are installing is growing at a double-digit pace in the last, let's say, 3 years. So there's a strong demand on indoor and a strong demand on improving the capacity of single sites, where the single sites are normally dense area, where they need more performance. Not generally, let's say, movement to increase everywhere. It is a selective approach.
So let's talk about, you just mentioned there the idea of kind of indoor coverage as a potential kind of growth area, whether it's stadiums, hotspots, kind of transport hubs. Why should that growth, though, accrue, let's say, to Cellnex, which has traditionally been more of a kind of macro tower business than, let's say, kind of new third-party infrastructure players? I mean, so really, can Cellnex become a big player in indoor coverage for hotspots if that's where we're going to see more growth over the next few years?
Well, first of all, it is probably not known, but Cellnex is already number one in terms of market share on this type of services. Why Cellnex and not another one? Because this is also a market in which the offering is very fragmented. Yeah, because they are MNO offering these services, we are tower codes offering these services, small company offering this same service. What we can offer is to our customers, first of all, we have a relation with more than 30 MNOs, and you cannot operate a system, an indoor system, without the cooperation of an MNO. You cannot only build it. Second, we are already in place because we are a big company, but we have a very strong local soul. So we can, because we, at the end, this type of business is made side by side. So we have to negotiate with local authorities, you have to get a permit, you have to build the infrastructure. So there's a lot of this type of jobs that we do currently for the towers that are very similar for a similar job to DAS and small cells. So I think that we can offer a range of services, and I repeat, with the advantage to have already the MNO as customers, to our customers. In this case, moreover, there are also different type of customers, because once the MNO were used to take care of all indoor coverage. What the trend that we are seeing in the last years is that MNOs, also for shortage of capex, I imagine, they started to say, okay, we are very happy that you have this fantastic stadium, but sincerely, it's not my job to cover the stadium, because this is going to improve the service of your service, not my service. So
Yeah.
I'm spending money to improve your service. So sorry, you have to pay for it. So in this case, our customers, or for example, shopping malls, we have contracts with big chains in which, sincerely, the MNO is not so interested if the app of IKEA, for example, or works or not inside their shops. This is an IKEA problem. In that case, the final customer is not the MNO, but you always need the relation with the MNO to activate the systems. So it's a more complex environment comparing to towers.
And is that something, Simone, you see from kind of small cells being now Europe-wide as an example of future growth, or is that something you're seeing in kind of very specific geographies at the moment?
James, you are in the market, I think, since a long time, like I am. So about small cell, there has been a lot of talking. In 2015, I remember there was expected like 300,000 small cells each country.
Yeah.
And this didn't happen. It is not going to happen now. But what we see is that there's a growing interest about these type of technologies, especially in the last year, I should say. And I think there will be, we are not talking about hundreds of thousands, we are talking about thousands, but we finally see a real interest. I should say that we put as Cellnex we did our part of the homework, because also our offering, our way to offer this type of services changed very much in the last year, because we use much more advanced tool based on radio analysis, AI, and so on, to find white spots or places where the service is not good, and to propose this actively to our customers. I should say I was initially a little bit doubtful about the reaction of the customer, saying, are they going to appreciate it or not? Because in a certain way, we are suggesting them some improvements. I should say that the reaction was good, and we started to sell much more, also because we are proposing actively improvement in their network. So I don't know. On one side there is a trend. On one side we changed our go-to-market model. The result is that we are seeing growing double digit this type of offering.
No, so that's super interesting. So, Toko, that's also kind of interesting new growth where you're starting to feel more confidence on the indoor and small cell coverage. If we go back to just kind of broader use cases to drive wider adoption, I mean, you talked earlier, Simone, about things like kind of AI, FWA, more kind of 5G adoption within handsets. I mean, is there any one of those use cases that you would kind of specifically single out that you think is really going to be a bigger driver of then demand for more tower infrastructure?
Yes. Well, I can elaborate quickly also on all of them because I think they are all interesting. Well, the first driver is, of course, handset penetration. Because if we look at the statistic, let's say that someone says 15, someone says 54, but let's say 50% more or less of the handsets are 5G and the other are older technologies. To pass from a 4G to a 5G handset, increase traffic per 2.5. So approximately 25 giga, big averages each month. Only this is a big driver, considering that this penetration is adding more or less 10 percentage points each year. So this is, I think, the main driver in terms of traffic growth. At the same time, there's a FWA that is growing not as much as the handset penetration, but I repeat, 25 giga a phone, 500 giga a home connection. So it's true that the customers are numerically much lower, but the consumption is incredibly higher. So these are two classical trends. AI is appearing now. Is still a single digit share of traffic, but what it changes is that latency and balance between uplink and downlink is very different. When you speak about normal internet, now typical normal services, including streaming, for example, and Netflix or something similar, normally the ratio between uplink and downlink is 1:10 or 1:8. It depends how the network is configured. When you go to cloud services, you already go to 1:1. So more or less the data transmitted and received are the same. When you go to AI, is a little bit intermediate, let's say 1:2, 1:3. This seems a detail, but it is not, because consider that a device is built to have a download that is much easier than an uplink. Why? Because on one side, in the download, you have a powerful antenna transmitting to a small antenna on your device. When you do the uplink, you have a small and weaker antenna transmitting to the big one. It's true that there's a lot of evolution in terms of sensibility on the towers on this, but it is essentially not the same. So what do we expect on this side? It is not a big increase in number of towers, but increase in terms of equipment, because one solution, typical solution in these cases, is to split between downlink and uplink in terms of frequency, so to use a higher downlink frequency and a lower uplink frequency. This will imply reconfigure the towers more than increase the numbers. But at the same time, indirectly, if you want a low latency and you want a big throughput, you need a nearby antenna. These things work in hundreds of meters, not kilometers. Otherwise, the performance are not so good. Talking about 5G SA is quite similar. A small premise. GSM has been a fantastic technology for one reason. No, for many reasons, but the main one, in my opinion, is that it was a simple technology and the same everywhere. So this was super favorable for diffusion of the technology, and the success is very clear. But on the other side of the moon is that this type of service is best effort, has always been best effort. So if you look at, for example, a fixed connectivity, you historically you could choose different quality of service depending on what you do. You are a simple consumer, you are a company, you are a bank. Normally, your requirements in terms of quality of service are completely different. This was not possible to apply to cellular phones. Now it is possible because 5G introduced these type of features like quality on demand, like slicing, quality of service, generally speaking, but you need to update your core network to a real 5G network. Probably not everyone knows that mainly in Europe, what the MNOs did was to put a 5G antenna on a 4G infrastructure and core. This impeded until now to use these advanced features of the 5G technology. And we are starting now to see in some places, Spain, for example, where I live, is quite advanced if compared to other European countries. But we still miss the offering. Just by chance, today I received from my phone provider an offering saying, do you want this summer to use quality on demand? First time in my life. So we see progress, but it's super early stage. Is going to impact? Yes, because to sell quality of service, you must have quality behind. Otherwise, you cannot sell it.
Let's dig in on that. It's important, Simone. So 5G SA, though, what you were talking there, what didn't come across to me, though, on all that kind of the core network upgrade and stuff is how does that, though, help Cellnex? So maybe you can give some examples on then how does 5G SA specifically, let's say, help your business as the tower provider?
Well, where we are seeing direct impact at the moment are specific cases like high density area. For example, stadiums, stations, and so on. In that case, the capability to have higher bandwidth and lower latency in a super dense environment is already visible. And also our places, think at a stadium. I saw this in Far East. Where you are there, you want to post your Instagram, your picture on Instagram. You are in that moment probably ready to buy a €3 upgrade on your speed. So quality on demand, these are services that in that environment works quite well because in that moment, you give value to have priority and to have a better service than the others, especially in a congested area. In general, we are not seeing so much until now, but what we expect, I repeat, if I want to sell quality of service, I need quality. And if I need quality, I need density. And if I need density, I need to build more towers or to host more POPs. So that's what we are waiting for.
No, that's pretty clear. I think, general message is kind of more density, more hotspots coming. But I also wanted to pick up on something you said in the previous answer as well around AI and the need that more uplink might require network configuration or reconfiguration because network reconfiguration generally can be quite good for tower companies. So can you give us help? I mean, when you're talking to MNOs in your discussions with them, are they already planning network reconfigurations over the next kind of few years to be able to deal with what they see as rising AI demand, or is it just too small at the moment?
Well, we are starting to see it. This is another thing we are working heavily and also to provide different services because traditionally, for example, for a customer to collocate, the time from the demand, from the identification of the willingness to do to the delivery was quite high. Why? Because this type of work was made mainly manually. Today, what we developed internally, this is on industrial engineering part, we are digitalizing all our park and we are able to simulate real-time adaptation works needed to host a potential customers. This is helping very much in our value proposition to our customers. And yes, what we see is that despite the peak of 5G development is already behind our shoulder, because now, of course, a big part of the network has already been deployed. What we see is that we continue to work on the C-band improvement, because
Yep.
the mid-band usage of 5G is still in a development phase. And we see this also indirectly about our adaptation work. What we see is that despite the peak of deployment of 5G is already gone, the level of activity we are registering is not going down. So what we see is that network is live. Is continuously evolving, and customers are continuously asking us to evolve it. So I think the future would be much more than today, but we already see something.
And then for investors looking at your business, let's say quarter to quarter, you report the kind of KPI sheets as you have. I mean, what do you think investors should be looking out for in your reported metrics, over the next coming quarters, years, where all of these trends we're going to talk about or we've talked about will become, let's say, more visible to external observers of Cellnex?
Well, I think that these changes are not going to impact our way of measuring our KPI. At the end, we are talking about mainly network densification. So the KPI that are important are the same. So sites that we build, POPs that we are developing. So let's say organic growth. This I think is the main is one of the main. Then is another interesting thing, despite the fact that they are still building new towers, and new towers, they normally at the beginning are mono-tenant, because there's someone that is asking us to build towers. Despite the dilution effect that we have within the new build tower, our tenancy ratio, so the number of customers on the tower, is still growing. So as much as our average revenue per tower. So I think these are the main KPIs, not different from yesterday, but important to look at.
Got it. Okay, now that makes sense. Now, kind of, I suppose a lot of observers of your share price will have, seen that unfortunately it has been under pressure of late. And I think one of the drivers for that is kind of rising concern about satellite as potentially a substitute technology for tower companies. So maybe what would be great to get kind of your thoughts are as, to what extent you think it could maybe act as an alternative, as a replacement for terrestrial networks, in particular in rural areas.
Well, I think that there's a little bit of confusion about what the satellites' real now performance are. I think personally that is a fantastic technology, because at the end there's a percentage of the Earth, and all the sea, if you want to add it, that today has no service. Because are remote areas, because there's no way to serve this in an economical, sustainable way, or really impossible for other reasons. So I think that satellites is a fantastic complementary technology, but with characteristics that are deeply different from terrestrial network. Terrestrial network are capable to replicate the spectrum every some 100 meters. So to you, the use of the spectrum, that is also, I can add, was very well paid, in the last years by the MNO, is super efficient, because we can reuse the same spectrum in hundreds or thousands of places. Satellites is not born for capacity or latency. It's born for coverage. It was born to cover areas where there's no other way, or not other economical, sustainable way to do it. So there are many limits, and the limits come from physics. So it is not simply an opinion. So we are talking about an object that is flying the lowest one, the last generation, is 350 kilometers in our head. That runs at 27,000 kilometers per hour, and that also, if as a big can have a big backhauling, is covering an area of hundreds of square kilometers. So it's obvious that the capacity of the satellites should be shared between all the people using the service inside the cone. This is rapidly led rapidly to collapse the capacity of the satellite, where the density of population is not high, is simple middle low. So if we are talking about extreme rural areas, no doubts that there can be an interest in services, because today, let's say, apart from governmental programs, is covering this area. But if we are talking to also rural, suburban or urban, sincerely, the technology is not the right one. Not talking about cities, because there's not only problem of density, there's a problem of canyon effect. No one talks about this, but the satellite is moving. If I am in a street, I have buildings at sight. So my line of sight with the satellite, it lasts very few seconds, because the satellites go rapidly, and the cone that I see from my cellular phone in line of sight is super small. There are calculations we did just to simulate what would happen in Barcelona, and what our study tell us that practically nowhere in the city there's a reasonable way to use direct to device. You should be in the beach. You have to stay in a park, somewhere where your line of sight is big enough to maintain the signal for more than 10 seconds. So I think that to complement is fantastic, but to substitute is simply impossible. So, or at least it's impossible until now. In next 20 years, only God knows. But the satellite technology is not built to substitute terrestrial.
But let's just to play kind of devil's advocate on that, because I think it's an important topic for a lot of investors at the moment. Towards the beginning of that answer, Simone, you talked about, mobile towers repeating every 100 meters or so, so I would agree with you. I think in urban areas, and the canyon effect you talked about there is interesting. I do think they have real limitations. But if I look at Starlink's latest filing, they're talking about narrowing that cone radius down to 6 kilometers. They talk about in their latest filing. Now, see, they haven't yet deployed those satellites, but that's what they're talking about. That's not that dissimilar from a cone radius or a tower radius actually in a rural area today. So I'd love to get your thoughts again, just to push you a bit more on maybe if a tower radius becomes similar to a cone radius that Starlink can deliver, couldn't it become more of a threat in rural areas?
Well, for what we could study on that, there's been forming. There are many technologies that are emerging, but also with the new generation of satellites, and also thinking about, let's say, 40,000 satellites, that we are not there, of course. So thinking to a much stronger deployment, this, in our opinion, talking about direct to device. Then if we talk about fixed wireless access, it's another story, no? But because of different frequencies, different service, but also with the new specification, we see that serving 10% of population worldwide would imply to have something like 2 megabit per second available for handset. So is it useful? Yes, of course. If you are in the middle of nothing, it is fantastic. But it's sincerely hundreds of times less than you have with a tower. And let's say that 60 kilometers is a diameter that can be good for the rural part. For cities is unthinkable. We are talking about hundreds of meters. So I repeat, it's a complementary technology with the future evolution, probably in the rural areas, can offer better services than today, that's for sure. What we see in terms of our internal calculation is that the real impact that can be, for example, not to build a tower, no, but use only satellite on our entire park could affect probably some hundreds of new potential towers, because where it's already built, no one is so full to dismantle the tower. It's costly to dismantle the tower. So at the end, the risk that we see is sincerely not significant.
No, and I mean, at the end of the day, I agree with that. I think even if the cone radius can be similar, just the level of spectrum satellite companies
Efficiency,
have
yeah.
is a tiny fraction. And I think there can be major issues on indoor coverage as well, which means I thought it can, never replicate what a traditional cellular
Yeah.
network can actually do today.
And power consumption, battery consumption on the phone. There are many, I repeat, it's a fantastic technology where there's no alternative. But if you have a not traditional alternative, it's difficult to say that it's better. There are many limitations.
So let's think you kind of gave an interesting number there that like even if this could succeed, maybe for your future tower build, there might only be like 1 or 200 towers where an MNO might look at a satellite solution instead for future growth. How much of your actual kind of densification you see across the network today is rural versus urban?
Well, the densification is mainly urban and
It
suburban.
is okay. Yep.
Because rural is typically driven by governmental programs. So it's a place when, let's say, if you had to build only for economical reason, probably you would not build. Okay. So this type of programs helps operators that normally share much more than in urban, the towers. And then our customers, what they do is to try to monetize more through FWA, because normally in these areas the fiber connection are difficult to find, let's say.
But
But
if we
it's
include, Simone, sorry, can I just interrupt there a second? If we include
please.
the kind of growth that is coming from some of these governmental programs, how much of your current growth of tower site count is actually rural? Because I'm kind of thinking, could there be a scenario where governments in future might not want to kind of subsidize that and instead would look at satellite in future? Or is still, even with the governmental programs, the majority of your tower growth is actually still in urban areas where satellite is less of an issue?
Let's say that the rural part is not the biggest part of our business. It's a
It's
smaller
not
part.
really.
And at the same time, until today, tomorrow, who knows? But until today, the coverage obligation are from terrestrial network. So it is not said also that having a good service in the rural, this would be accepted by the government or by the regulators, are a substitution of terrestrial network. Also because I should say that in rural, normally towers are used not only for mobile. When we build a tower, we have the land, we have the power, we have the mast. These are normally used also by firemen, police to put their equipment. So it is not a one service only. It is used by all the community to put their necessity in terms of communication. So it's not easily to not to have it. But yes, of course, if you are talking about areas in which you have a population density that is really, really low, could be that in the future also satellite could be accepted by the regulators. Today it is not, anyway.
So I mean, I'd agree with you that I think it's going to be very difficult, if not impossible, for satellite to replace terrestrial mobile services. But is there a scenario where could it even be positive for towers? I mean, is there a scenario, could MNOs today switch from maybe using microwave or fiber backhaul? Could they actually look at satellite for backhaul? Is that something that maybe then could be even like an incremental revenue source for mobile towers?
Well, the incremental part at the moment is more related to base station because the satellites
Yeah.
flies, but somewhere has to connect to the terrestrial network. So what we are doing today, that is a new line of business. I'm not talking about billions, but it's interesting because a base station for satellites is very similar to a tower. They need space, they need energy, a lot of energy, I add. They need a permit to install. So it's very similar to our core business, and we are already building, and some are already built, this type of new service. On the backhauling part, I think that satellite backhauling is useful where there are really no alternatives, because also microwave and fiber, okay, but also microwave normally is preferable. There are places in which it is not convenient. Yes, in that case, satellite can be good, but what we see that is used more as a backup backhauling. So if the main connection goes down, they can
Yep.
use satellite to connect. Can be an increasing can increase our revenues. Yes, marginally, because if we host a microwave and we decide to take it out to put a satellite, well, we are losing someone and adding someone else. I don't see it as a strong revenue line or
Okay.
revenue line.
Okay. No, that makes sense. So what about, I mean, just kind of moving on, talking about kind of other topics. I mean, another area regulators in Europe have been focused on or talking a bit about is kind of 6 gigahertz spectrum and maybe making that open to MNOs towards the end of this decade. If that were to happen, how could that, do you think, affect what we see for tower demand?
Well, we get back to physics, no? Higher capacity, higher frequency. Higher frequency is less propagation and indoor penetration. So the more we increase the frequencies, the more towers point of presence are needed. I don't say towers because there are places in which you can simply co-locate. You don't need to build a tower. But let's say that you need more point of presence. So if this will happen, for sure there will be an increase in performance, but at the same time, more necessity to get nearer to the customers to be really effective. Also because indoor penetration of, say, 6G starts to be quite low. So it's another factor that give us confidence that this trend of densification is going to increase. It's written in the stars. It's a mathematical issue. If we continue to increase frequency and continue to increase traffic, there's no other way than to densify. And densification means more infrastructure, physical infrastructure.
And have you seen in your discussions with mobile operators, are they actually talking to you about thinking about kind of future plans over the next 5, 10 years for deploying the 6 gigahertz spectrum band and the network architecture required for that?
It's just a starting point. I should say that, and this is another point. No, we are part of the bigger value chain. We are not alone. We are not a self-standing product. We are part of the value chain. So on one side, we see the demand. The demand is there. The traffic is growing. The network are degrading in this moment, especially in many places in Europe. But on the other side, we need people that have capability to invest. And this capability to invest is subject to how things are going to evolve in the next future in Europe. Are the regulators thinking to change something or not? Because it seems that they are thinking about a new approach. Because we should say in the last 20 years, the focus of the regulators or the government was the massification of mobile communication. So the idea was to make it accessible. I remember when we launched many years ago, these type of services. I was in Italy and I used to pay the equivalent of 1.5 euro per minute to use the phone. Now it's clear that that type of the level of cost could not be sustainable for a massification. Now, probably we apply after 20 years or more applying the same recipe. We are getting to such level of ARPU, such low level of ARPU that is really difficult for MNO to think about increasing their capex. And what we see is that Europe is remaining behind Far East and United States. There are many estimations that it's arguable, but you probably saw the GSMA report. We are talking about 270 billion only for new investment and 200 billion only to recover the gap that we have comparing to the best performers developed countries. So the question is who is going to pay that, but yes, the demand is there, and we will see how also the regulation is going to evolve to become a little bit pro capex, pro investment, and a little bit less pro street price, let's say, because at the end this is ending in something that is damaging the entire industry. So as usual, we have to find a new balance.
And I think probably one thing, you talk about kind of damaging the industry. One thing I'm sure we'll all have a kind of personal story on is we'll have all been on a train journey trying to work or call someone and the network has gone down. That, most countries will see problems with mobile connectivity and transport links.
Yeah.
Is that something you're again picking up any realistic change that is happening there? Is that kind of business as usual, or do you think there are trends there that could change that again could impact what you're seeing in your business?
Look, we developed a specific unit to follow this type of opportunities that is called vertical solutions, because there are some, let's say, special coverage needed. And a big part is on transportation, because we are talking about corridors between countries, we are talking about tunnels, we are talking about trains. Getting back to the Japanese example, a Japanese passenger on the famous Shinkansen high-speed train, it has 80 megabit available each passenger. Here, if we have something on connectivity on the train, it's a miracle. So what we see is that on one side, the railway, the operators are starting to realize that this is a very important service for the passengers, because stay hours in a train without having the possibility to have a decent connectivity is not something acceptable anymore. But at the same time, also the government is moving in this. We saw now in recent ANACOM in Portugal, the Authority of Telecommunication, giving the spectrum for, let's say, much lower prices, but with strict obligation on coverage. Part of them are on transport, highways, trains, and so on. What was thought initially on train, especially, was the diffusion of the new FRMCS standard for signaling. Sorry, it's very technical, but it's the signaling system of the train that should have been ready in 2025, that moved to 2030, now 35. So I don't think this will be the main driver for this type of coverage. But yes, the gigabit train is something that more than one railway operator is looking at. Also realizing, finally, I add, because I'm working on that, I think at least since 11 years, that this is a service that is made for the passenger of a train. It is not made for the MNO. So they start to understand also that they have to pay for the service. And at the end, the passenger should pay for the service. But I think that each one of us will be very happy to pay 50 cents of euro more to have a real connectivity on the train. So I think that the business model is changing too.
So, Tessa, I was excited about what you said about Japan there and the bullet train. So, for those of us that aren't as familiar with the Japanese market, what have the mobile networks done there to allow for that kind of speed on the bullet train? You know, what would have to happen in Europe to be able to replicate that mobile service on high-speed rail links around Europe?
Well, this is a more general question, James. Let's say that they have one order of magnitude more of POPs. No, this is generally speaking. So if we talk about 20, 30,000 times, 30,000 there, they speak about 200,000, 300,000. So this is a starting point. But specifically on train, what it works is what is called the radioelectric tunnel. You need to build a specific network only for the train that is made of one tower, more or less each 1 kilometer. And the train should be equipped with special antennas that normally is the beginning end of the train. And in this way, you can provide more than 1 gigabit for antenna. So let's say that in function, depending on the number of antenna on the train, you can offer quite a big let's say, backhauling for all the passengers. Then there are some other internal intervention of the train for the repeaters, but this is very technical stuff. What you need is a radioelectric tunnel and dedicated antenna. There is nothing rocket science. It is quite easy to build. Of course, should be financed.
But to be clear, that's an area of potential, like future business that you would see as an opportunity for Cellnex. It's not the railway owners are kind of shifting that business to someone else in the value chain. Is that fair?
We see it as an opportunity. Then we are already in talks with various railways operator. Not all the countries have the same orientation. Someone want to manage personally. Someone are more open to, let's say, outsourcing model. We did recently a proof of concept that was quite interesting on a train, a high-speed train in Italy. We covered some tens of kilometers. The performance are there, the technology are there. The business model, I think, is evolving in the right direction. So for us, it's an opportunity. Then, of the approximately, 70,000 towers, more or less, to be built to cover high-speed lines, are they all going to tower codes? Probably not. But there's an interesting opportunity anyway, also taking a share of this potential market.
So, Simone, can we come back and talk a bit about the topic of FWA a bit? Because for all the talk about 5G SA, AI, all this stuff, personally, and this is my personal view, one of the probably the biggest driver of actual demand growth and need for capacity could well be FWA. And I suppose if I look at the markets you're in right now in like Italy and the UK, we have MNOs that seem to be very incentivized and looking at pushing FWA kind of as a specific product. It can save them wireline wholesale fees. So there's an interesting model for them to look at. So really question for you is let's talk about Italy and the UK where FWA is a bigger phenomenon right now. Are you seeing there the mobile operators thinking about kind of reconfiguring the network, let's say in a different way to meet future FWA demand than let's say in markets where the MNOs might be slower to deploy FWA?
FWA is an interesting case, no? Because it's the demonstration that many times technical stuff is not what interesting for the customer. Because if you look at when you look at the reason why people is buying FWA, well, there are different cases. No, the easiest one and the one for which FWA was born was the rural areas in which fiber is not present, and so this was a way to have a high performing connectivity without having a cable. okay, because it simply was impossible to buy. And for operators was quite a good deal, no? Because at the end, this absorbs a lot of capacity, but in this area, normally the towers are relatively empty, let's say, in terms of load. They are not so much loaded because they are low density areas. Now, what's happening? What we are seeing is that, or there are operators that simply do not have the fixed line, or there are customers that are not so interested in having 1 giga connection at home, but they want what they need to satisfy their basic needs. The basic needs is to navigate in internet and to look at a movie when I want. In that case, they are with a 200 megabit connection. They're more than happy, and in that case, they benefit from the fact that a fiber connection should be installed. You need an appointment. You need people coming in your house installing cables. You have to wait for the cable to be installed. There are a lot of, let's say, small problems, no? In this case, with FWA, you go to the shop, you buy the modem. The modem is inside the SIM card. You enter, you turn it on, and you are working. You move to another house. You take your modem. You take it with you in another house. So what we are seeing is that there is a development also in urban areas. Now, is the most intelligent use of the spectrum? In my opinion, probably it is not, because normally where there are dense area, to have such a heavy users probably is not the best choice. It's a short-term choice, better said, because you get a 30, 40 euro ARPU from one customer, but it's a customer that is consuming 20 times what is consuming a normal user. It's more a choice of the MNO, of course. For us, it's only another push to increase the density, because the more traffic is generated, the more density is needed. So it's a positive effect. But it's strange. There are places in Denmark too, we are seeing this. People is increasingly using FWA instead of fiber. Also, if fiber is present. Yep. Spain, not so much, because fiber is so capillary that sincerely it's difficult to use another technology.
But specifically, have you seen, sorry, just to go back to, let's say, UK and Italy, any evidence there of operators kind of thinking about configuring their network slightly differently for future FWA demand?
Yeah, in that case, well, our simulation, in Italy, there are, if I'm not wrong, something like 2.8 million customers in FWA overall. Let's say that a 1 million customer increase would result in a single-digit growth on number of towers needed. Single digit, I mean, ranging from 3-4% to 8-9%. It depends, of course, of the scene. This is a calculation we are doing, and the customers are growing. So will be 1 million. We don't know. We did the simulation, but for sure, if I'm not wrong, I don't remember if I know Ericsson report or GSMA report. What is forecasted is that the today 28%, if I'm not wrong, share of traffic that is used by FWA is going to 36%. So the share of traffic is growing on an overall base of growth. So it's growing more than the normal growth.
Interesting. I'm pretty bullish myself on that area, so it'll be interesting to see how that develops. Now, I know we're almost up on the hour, but I just wanted to touch on two very quick other topics, so kind of slightly rapid fire. But we see MNOs, buy millimeter wave spectrum. So I've kind of heard about millimeter wave spectrum for 20 years, and nothing really of major significance, I'd say, seems to be happening quite yet in terms of deployment. I mean, anything at all you're seeing that might change that in the coming kind of few years?
Well, based on my experience or what we see in the market, I should say that millimeter waves is not a very widely spread technology, let's
Not
say.
okay. No, fair enough. No, no. Well, you've given a lot of plenty of other examples where there are some kind of good
Look,
growth
we used it.
opportunities.
We use it. We did some specific locations, outdoor location with high density, but also going back to Far East. Also in Far East, they are not using it. The only probably one of the most developed base, let's say technological bases in the US, if I'm
Yeah.
not wrong, with T-Mobile, but is such a high frequency, they have a lot of problems. So I think that with the capabilities that today mid band, also 5 gigahertz, 6 gigahertz can offer, go to 30 gigahertz is really challenging.
Yeah. That makes sense. And then kind of last question I was going to have was just on the topic of edge data centers. And again, is that anything you're seeing any kind of change in demand or interest for from the operators in particular? You were talking about AI and latency at the beginning. Just be great to get your latest thoughts on whether that could be an emerging opportunity.
Well, I think this is an opportunity, but I think we have to frame it correctly, because if we think about a super wide development of edge, I don't believe sincerely it's something we will see in the short term. This is another of the stories we are hearing in the market, at least since 10 years or more. What we experimented is that the need for such a nearby calculation to the customers until now hadn't find the right application, or said in other words, there were no application that needed this to save 10 milliseconds from the tower to the data center, or 20 milliseconds. Probably AI is going to change something in this balance, because AI can, first of all, is an application that is already there. So we don't have to wait for a fantastic new application that no one knows what it is. So AI could be probably take profit to distribute the processing power from big data centers to edge points. And we are in a fantastic position to offer these type of services, because we have the real estate, we have the energy, we have the backhauling, and we have the customers. No? So in this case, I think there will be, in the future, there will be an opportunity, especially on inferencing, in AI. So to move, well, it depends on the architecture, but to move a reduced version of LLM locally, and then to go to the data center for different needs, or other architecture that at the moment are not known, but to add processing power at the edge could be something this time realistic. We are not seeing the market still yet, but it's credible.
Interesting. Okay. Now, well, that's a good kind of positive note to end on when we kind of look forward to the future, because I think it's been fascinating everything you've said today. I've been kind of jotting down some notes here, and when I kind of look at your business, we've already seen over the last year or two an inflection in your underlying tenancy growth already. And then you've been talking here, I've got kind of more indoor coverage, AI uplink, FWA, 5G, SA, kind of transport connection, maybe the 6 gigahertz, more people going to 5G handsets, government requirements still to be deploying in rural areas. There is a lot going on with your business that could be kind of interesting new opportunities for growth. And in
Yeah,
particular, you're seeing that in some of the contracts you sign with the MNOs that renew with you.
yeah. Well, all the signals sincerely are positive. Of course, there are some headwinds, but that's life. No, what is less clear is the timeline, but the destination. I don't know. We probably don't know perfectly well what will be the route, but the destination is clear, and everything is making us think that traffic increase, quality needed is higher, AI is growing, FWA is growing. all these signals are driving us to think that our business is a solid base in the future. Then it will be tomorrow, it will be after tomorrow, it will be today. It depends very much on other factors too, but that we will get somewhere with a better and bigger infrastructure, that for sure. This is our view. So we are positive about future.
No, well, that's great. That's a great note to end on. So, Simone, thank you very much indeed. Thank you to everyone who's joined us today. And if anyone would like to follow up, do let us know. But yeah, thank you, everyone. Yeah, good afternoon, good evening.
Thank
Thanks.
you and good afternoon.